So to do the integral of arcsin squared of x, we need to use integration by parts. If we let u equal arcsin squared of x, then dv needs to equal dx, which means du is equal to 2 arcsin of x over the square root of 1 minus x squared if we use the chain rule, and then dx, and then this means v is equal to x. If we apply the integration by parts formula, then the integral of arcsin squared of x is just equal to uv, which is x arcsin squared of x minus the integral of v du, which is minus the integral of x times 2 arcsin of x over the square root of 1 minus x squared dx. We can bring out the constant of 2 in the integrand and rewrite this as x arcsin squared of x minus 2 times the integral of x over the square root of 1 minus x squared times arcsin of x dx. So what we need to do is apply integration by parts again. If we look at the integrand, we can let u equal arcsin of x and dv equal x over the square root of 1 minus x squared dx. So this means du equals 1 over the square root of 1 minus x squared dx, and v equals negative square root of 1 minus x squared. And I'll just say that the integral of x over the square root of 1 minus x squared is just negative square root of 1 minus x squared, and I'll show you very quickly. So here's how we integrate x over the square root of 1 minus x squared. We first take out a constant multiple of negative 1/2, so this becomes negative 1/2 times the integral of negative 2x over the square root of 1 minus x squared dx, and then we can substitute u equals 1 minus x squared, which means du equals negative 2x dx. So this integral becomes negative 1/2 times the integral of 1 over the square root of u du, since we replace negative 2x dx with the du, and then 1 over the square root of 1 minus x squared just becomes 1 over the square root of u. So if we integrate this, the negative 1/2 stays the same, and then this just becomes 2 times the square root of u. If we use the reverse power rule, and then we have to plus some constant c, and then this just simplifies to negative square root of u plus c, and since u equals 1 minus x squared, this is just negative square root of 1 minus x squared plus c, and that's what we had earlier. Alright, so now we can do the integration by parts. The x arcsin squared of x stays the same, and then this is followed by minus 2 times uv, which is negative square root of 1 minus x squared times arcsin of x minus the integral of v du, which is minus the integral of the square root of 1 minus x squared times negative square root of 1 minus x squared dx. We can simplify the expression as x arcsin squared of x minus 2 times parentheses negative square root of 1 minus x squared arcsin of x minus the integral of negative 1 dx, since 1 over the square root of 1 minus x squared times negative square root of 1 minus x squared is just equal to negative 1. If we distribute the negative 2 into the parentheses, the expression becomes x arcsin squared of x plus 2 times the square root of 1 minus x squared times arcsin of x plus 2 times the integral of negative 1 dx. The integral of negative 1 is just negative x, and that's multiplied by a constant of 2. So the last term is just equal to negative 2x. So the final answer is just x arcsin squared of x plus 2 times the square root of 1 minus x squared times arcsin of x minus 2x plus some constant c at the end.